Welcome to the forefront of technology, where innovation meets exploration. Get ready to dive into the world of intelligence with TechBook. For many basic computing tasks like browsing the web, working on documents, or streaming videos, you don't necessarily need a dedicated graphics processing unit or GPU. GPUs are specialized processors designed to handle intensive graphics rendering for gaming, video editing, 3D modeling and the like. If you're not doing those types of graphics-heavy workloads, you can likely get by just fine using the integrated graphics capabilities that come built in to modern CPUs. Integrated graphics, also known as integrated graphics processors, IGPs, or integrated GPU, refer to the graphics rendering capabilities that are baked right into the same chip as your computer's central processing unit, CPU. While not as powerful as a discrete, dedicated GPU, integrated graphics can handle many everyday computing visuals quite capably. So if you're looking to save some money by skipping an expensive dedicated graphics card, or if you're using a laptop or small form factor PC that doesn't have room for a GPU, using the integrated graphics could be a perfectly viable solution. Here's a step-by-step look at how to enable and optimize the integrated graphics on your system. 1. Identify your integrated graphics capabilities. The first step is simply identifying what integrated graphics processor is included with your specific CPU model. On most modern systems, you'll likely have integrated graphics from either Intel, their latest offering is Iris-A Graphics, or AMD, their Radeon line. You can usually find this information on the specifications sheet for your particular CPU. 2. Check for updated drivers. Just like dedicated GPUs, your integrated graphics will perform best when you have the latest drivers installed from the manufacturer. For Intel chips, you'll want to grab the newest Intel graphics driver from their site. AMD chips will need the AMD Radeon software drivers. Installing these drivers helps optimize performance and ensure you have access to the latest graphics rendering capabilities for your integrated GPU. The drivers also provide access to control software that lets you configure display and graphics settings. 3. Access Graphics Control Panel. With the drivers installed, you can now access the control panel software to begin customizing and optimizing your integrated graphics experience. For Intel, it's called the Intel Graphics Command Center. AMD's is the AMD Radeon software. In these control panels, you'll see a wide range of settings and features for managing everything from video playback to gaming performance. Don't be intimidated by all the options though, you can keep things fairly simple. 4. Adjust graphics quality settings. One of the handiest features in the control panel is the ability to globally adjust the quality level for graphics rendering. For most daily workloads like browsing the web or productivity work, you can set this to a fairly moderate level to balance performance and visual quality. Higher quality rendering does put more load on the integrated GPU. So if you notice any stuttering or lag during video playback for example, you can scale back the quality levels to ease up on the graphics horsepower required. 5. Optimize for specific apps or games. Another neat trick is that many games and graphic-intensive applications will show up in the control panel software, allowing you to adjust settings individually for each program or task. So if you do want to play some games on the side, you may need to bump up the graphics configuration specifically for the game executable to get smooth performance. The control panel makes it easy to create different graphics optimization profiles for different workloads you commonly run. That way, you're not wasting integrated graphics power on background tasks. 6. enable game boosting technologies. While integrated GPUs can't match dedicated graphics cards, both Intel and AMD have developed technologies to help boost and optimize gaming performance on integrated solutions as much as possible. Intel has Say Graphics Game Sharpening and AMD has AMD Radeon Boost, which use different upscaling and rendering techniques to help integrated graphics punch above their weight for light gaming sessions. You'll find options to enable these in the graphics control panels. 7. Adjust power and thermal settings. One thing to keep in mind is that integrated GPUs share power consumption and thermal loads with the core CPU. So in the graphics command software, you'll also see settings to help balance performance with energy efficiency and cooling requirements. For systems that tend to run hotter or where battery life is important, you can customize the integrated graphics to favor an quiet or balanced thermal profile to keep heat output under control at the expense of some graphics horsepower. 8. Leverage multi-monitor support. A nice advantage of integrated graphics these days is robust support for multiple monitor setups right out of the box. The graphics command centers make it easy to configure and extend your desktop across multiple displays seamlessly. You can also play around with settings to determine how graphics rendering workloads are balanced or dedicated across each monitor. This gives you some added flexibility if you need to prioritize performance for a particular display. 9. Offload video encoding/decoding. Speaking of flexibility, both Intel and AMD have built-in media engines into their integrated GPUs that can take video encoding and decoding tasks off the main CPU for improved efficiency. In the graphics command software, you can enable options to automatically offload video processing to leverage this hardware media acceleration. 10. Know the limitations. While integrated graphics have made massive strides in recent years in terms of performance capabilities, they definitely have limitations compared to discrete GPUs that power users need to understand. You'll want to temper your expectations around using integrated graphics for demanding video editing, 3D modeling, or playing extremely graphics-intensive modern games. For true workstation-level multimedia editing or gaming at highest settings, a dedicated GPU is still the preferred solution. But for so many of our day-to-day computing needs, integrated graphics are more than capable. They can handle media playback, productivity work, light gaming, and basic 3D rendering without batting an eye. And they do so extremely efficiently in terms of size, cost, and power consumption compared to beefier discrete GPUs. So in closing, if a dedicated graphics card isn't a necessity for your computing workloads, don't overlook the integrated graphics capabilities that may already be baked into your CPU. With a few settings adjustments and configuration optimization, you can squeeze every ounce of graphics performance from your integrated GPU to enhance your daily computing experience. Just be realistic about your needs and you may find integrated graphics are the perfect solution. With knowledge as our compass and innovation as our guide, there's no limit to what we can achieve. Stay curious, stay inspired, and keep pushing the boundaries of what's possible. Like, share, and subscribe for more captivating content on TechBook.